So yesterday we stopped at path of contact derivation. So we had an equation for path of contact, similarly for arc of contact and contact ratio. So please note all these equations. I required these equations for problem solving. Okay. So before starting problems, I'll tell you what are the different types of teeth profiles. You know that teeth in gears, but you don't know what is the profile that you used to produce the teeth. So that profile is required because for better performance of the gear, profile is required. You cannot simply do something and make a gear. So what are the different profiles used for gear making? They are involute profile and cycloidal profile. I'll just tell you what is these profiles actually mean, and more we will discuss later. Okay. So involute profile, you can see a video. From this you can think what will be the involute profile. This is a involute profile created. So only this is very simple. You just see, you can see a circle and what is moving, a line is moving, and what is that, what is the nature of that line? That line is actually tangent, right? At each point it should be tangent to the circle. So the tangent is keep on moving, so it's actually the tangent keep on rolling. So when tangent keep on rolling, one point in the tangent will create a profile, create a curve. That curve is called involute profile. Again you see once more. Okay. So curve generated by a point on tangent which rolls on the circle without slipping. So whenever we say rolling, slipping is avoided. So slipping should not be there. That's always you have to write. This is a definition of involute profile. This is most of the gears using this profile. The next is cycloidal profile. First you see the video. Now you see we have a circle, green color circle is there. So circle is rolling on a straight line, right? On some path it's rolling, it's a straight line. When circle rolls, what is drawing? A curve is drawn from where? A point on circle. So a point on circle produces a curve. So what is the nature of that point? That point is on the circumference of a circle, and that circle is rolling without slipping on a straight line. This is cycloidal curve. So very simple. How will you define? It is a curve generated by a point on circumference of a circle which rolls without slipping on a straight line. Sorry. Definition. Okay, please note the definition. Curve obtained by a point on the circumference of a circle which rolls without slipping on a straight line. So this is called a cycloidal profile. These are the important profiles used for gear teeth making. Okay, so next is pressure angle. So you read that definition first. This angle between common normal to gear profile and common tangent to pitch point. Okay, so you have to find two lines. One is common normal to gear profile. Next one is common tangent at pitch point. So first you will see what is the common tangent at pitch point. So what is pitch point? Pitch point is where both pitch circles meet. So what will be the common tangent at pitch point? Tangent to both the pitch circles. So you can see both pitch circles in the diagram. One is this, other is this. So this pitch plane, they wrote it as pitch plane, that is your pitch circle. Okay, this one. This one is your pitch circle. Okay. pitch point. That is your common tangent at pitch point. Next is common normal to gear profile. So which one is common normal to gear profile? Like gear profile, the teeth profile only shown here, and a line passing through the tangent is passing through one point, or the tangent is this one, and the one perpendicular to that tangent is your normal, that is this line. Okay, this line. So that line is shown here, so that angle between these two lines, okay, this line and this line, this angle is your pressure angle here for alpha. Now in our previous diagram we'll use it is represented in alpha in the previous slide, but we represented in our expressions phi. Okay, now you see that phi, we use phi at two points, two positions between C2 and C1. This angle is why I told that it is pressure angle, and I will define it later. So here also you have to find the two lines. Okay, one is common tangent to pitch, common tangent at pitch point. So which is pitch point? The point P is pitch point. So that pitch circle, so that pitch circle will pass through like this. Another pitch circle will pass through like this. So this is so a line drawn through pitch point. This will be your tangent, common tangent. Clear? And which one is your normal to teeth profile? So the line MN will be the same line which is normal to your teeth profile, because we know that this is a tangent to both base circle, and this line, base circle means where the teeth start beginning. Okay, teeth begins at base circle, below that there is no teeth. So that at that beginning point, this will be perpendicular to the teeth profile, or this line will be perpendicular to teeth profile, or that is a normal. So this is the normal. Okay, and this this one is your common tangent at pitch point. So the angle phi will be this. Sorry, I wrote it as angle phi will be this. Now how this phi came here? Okay, that you just see. First you see the line C1, P and C2. Okay, so this is common tangent to both pitch circle. Therefore what we can say, the pitch circle centers are C1 and C2. So this angle is 90 degree. This angle is 90 degree, that you know. When that angle is 90 degree, what will be? This is phi, and the total angle is 90 degree, means this small angle. This angle will be 90 minus phi, right? In the triangle C1PN, this angle will be 90 minus phi, because the total angle is 90. So when this is 90 minus phi, again the other side we have phi, because this is a right angle triangle and this angle is 90 degree. So this will be phi. Similarly on the other side, if you check, we will get the same phi here also. Okay, now you understood why the phi came there. Now pressure angle is another important parameter we are using to represent any gear profile. So I will go to problems. So first problem, just read the problem. Number of teeth on each of the two equal spike gears in mesh are 40. The teeth have 20 degree involute profile. The module is 6 mm. The arc of contact is 1.75 times the circular pitch. Find the addendum. This is the question. So any question, the first step is to write the given data. So what are the given data? Two gears in mesh having equal number of teeth equal to 40. So you can write capital T equal to small t equal to 40, because we use capital letter for larger gear and small letter for smaller gear. Here both are same, so you can write capital T equal to small t equal to 40. Next is pressure angle is given phi equal to 20 degree. Okay. Next, module equal to 6 mm. What is the definition for module? M equal to d by t. So d by t equal to 6 mm. So also equal to small d by small t. This is equal to 6 mm. Now you see from here, already t is given as 40. Both are 40. So module is given as 6 mm. So what will be capital D? 40 into 6, 240 mm. Similarly, small d also 240 mm. Okay. Therefore, what we can write? Capital R equal to small r equal to 240 by 2, 120 mm. Clear? Then next, ഓക്കെ, അപ്പോൾ അത് പുറത്തോട്ട് പോയതാണ് ഡിസ്റ്റർബൻസ്, അതുകൊണ്ട് പൂച്ച കിടന്ന് കരയുന്നു. ഞാനിത് ഓൾറെഡി റെക്കോർഡ് ചെയ്ത സാധനമാണ് വീണ്ടും റെക്കോർഡ് ചെയ്യുന്നത്. ആദ്യം റെക്കോർഡ് ചെയ്തപ്പോൾ പൂച്ച കിടന്ന് കരഞ്ഞ് ഫുള്ള് ശബ്ദം കേട്ടു റെക്കോർഡിൽ. അങ്ങനെ ഞാൻ കളഞ്ഞിട്ട് വീണ്ടും ചെയ്യുവാണ്. അപ്പോൾ വീണ്ടും കരഞ്ഞു തുടങ്ങി. അതാണ് ഞാൻ അത് മാറ്റാൻ പോയതാണ്. ഓക്കെ, നമ്മളെവിടെ where we stopped, module, and so you got capital R and small r equal to 120 mm. The next sentence, arc of contact is 1.75 times circular pitch. So you can write arc of contact equal to 1.75 into PC. And what is PC? PC equal to pi d by t, right? Now you can use another term. D by t is already module, so you can write PC equal to pi m. So also equal to pi m. So what will be PC? 6 into pi, 6 pi. So you got PC. So if you multiply into 1.75 will give you arc of contact. So you got arc of contact also. Okay, find all these things. Okay, I'm not finding anything. I'm just telling the equations and required things. Now you read what you have to find. You have to find addendum. That's your question. So what is addendum? Remember the definition. Addendum is the radial distance between top of the teeth and pitch circle, right? So how will you get an expression for addendum? Take the center of a gear. To the top of the gear, what is the distance? Radius of addendum circle, that is RA. RA. And what is the distance up to pitch circle from the same center? That is pitch circle radius R. Therefore addendum is defined as RA minus R. So if you know RA, you can find you know RA and R, you can find addendum. But you know R now, but don't know RA. How will you find RA? Which equation carries RA? Remember, length of path of contact equation have the term RA. So you got arc of contact. Once you get arc of contact, what is path of contact? Again, you remember your definition. Path of contact arc of contact equal to path of contact divided by cos phi. So you will get path of contact from this. So once you get path of contact, you find the all known terms. Okay, all known and unknown terms you find. So I will write the different terms. I'm not writing the equation. You have RA, small RA, capital R, small r, and phi. These are the terms in path of contact. So left side is your length, that is known now. Right side is this. Okay. So you know capital R and small r. Okay. You know capital R and small r. Also phi you know. And what is capital RA and small RA? You don't know. That you have to find. But since number of teeth are equal, R and R are equal. Also module is equal. So what we can say, capital RA and small RA will be equal. So these two are equal. Now you substitute all the known values and this RA equal to RA, this definition also put in your equation. So you will get the value of RA in mm. So once you get the value of RA in mm, you minus reduce R from RA. So you will get the required addendum value. This is first question. You find it and send me the answer. Okay. Then one more question. Go to read the question. Pinion having 30 teeth drives a gear having 80 teeth. So what is pinion? Pinion is a smaller gear. Other one is, we called it as wheel. So smaller gear means you have to use small letters. So small t equal to 30 mm. Okay. T equal to 30 mm. So 30 mm. 30. T equal to 30. Capital T is 80. What else? Phi is given. Phi equal to 20 degree. Then pressure angle 12 mm module. Module equal to 12. Okay. Then addendum equal to 10 mm. That is 10 mm. Addendum is RA minus R. Or small RA minus. What you have to find? Length of path of contact you have to find, arc of contact and contact ratio. Those three equations you have to use. So I will proceed. You know the module. From the module and number of teeth you can find capital D and small d. So find capital D and small d. From that you find capital R and small r. So once you get capital R and small r, next step you use the addendum equation. Capital R plus 10 will be capital RA. Similarly, small r plus 10 will be small RA. Then you will get all the required parameters in your equation. Capital RA, small RA, R, small r, phi. Then you substitute and find path of contact. That's the first answer. Then what is arc of contact? Path divided by cos phi. So you'll get arc of contact. Finally, what is contact ratio? Number of teeth in contact. That is equal to arc of contact by circular pitch. Okay, remember circular pitch is pi times module. So you'll get the third answer. So all these answers you have to send to me. I'll tell you the time and all. This is all for today. Okay. Thank you.